Three charges plus Q plus 2Q and 4Q are connected by strings as shown in figure and are in equilibrium. What is the ratio of tensions in the strings AB and BC? So three charges plus Q plus 2Q and plus Q are positioned at A, B, C, and each charge is kept at a distance D. So let us take it as the tensions acting between AB and AC in this particular direction. At this point, let's take it as A, and this particular direction due to B and C, this is along this direction, right? So you have to take the ratio of these two tensions. As you know that tension is nothing but the force itself. So tension at A, I can write it as the force due to B due to A plus the force due to C due to E. So what is that? So force due to B due to, according to Coulomb's law, K into plus Q into plus 2Q divided by the distance between A and B is D square as per Coulomb's law, plus FCA is K into plus Q and the charge at C is plus 4Q divided by the distance between this D plus D, so that is 2D whole square. So what do you get? Q into Q square, so 2K Q square divided by D square plus 4K Q square divided by 4D square. So 4 will get cancelled out. So TA will be is equal to 2KQ square by D square plus KQ square by D square. So what you get? 3KQ square divided by D square. So write it as equation number 1. Similarly, tension at C, it can be written as force due to AC plus force due to BC. So substitute the values. K into plus Q into plus 4Q divided by 2D whole square. That is the distance between A to C. Plus BC is K into 2Q into 4Q divided by D square. So what do you get here? So here also 4 and 2 square will get cancelled out. So what do you get? KQ square divided by D square plus, here it is 4 into 2, 8KQ square divided by D square. So which is equal to 9KQ square divided by D square. So that is your TC. Equation number 2. Now compare equation 1 and 2. We have TA divided by TC, that is a ratio of tensions, which is equal to 3KQ square divided by D square. This whole thing divided by 9KQ square divided by D square. So KQ square by D square will get cancelled out. So what you get? 3 divided by 9, or if you simplify it, 1 divided by 3. So the ratio of tensions TA is to TC will be is equal to 1 is to 3. A uniform electric field pointing in positive x direction exists in a region. Let A be at the origin, B be the point on the x-axis, x plus 1 centimeter, and C be the point on the y-axis at y is equal to plus 1 centimeter. Then the potentials at the point A, B and C satisfy the conditions. The options are VA less than VB, VA greater than VB, VA less than VC, VA greater than VC. We know that the point A is at the origin, that is 0. B is located at a point plus 1 centimeter from A, and C is located at a point plus 1 centimeter on the y-axis. Okay. So as we know that the electric field is along the positive x-axis, that is given in the question, And electric field, we know that it is minus dV divided by dx. So electric field is from the origin to the positive x direction. So it is always from the high potential region to the low potential region. So if you calculate the potential at A at this point, and if you calculate the potential at B, VA is greater than VB. So the correct option is B. 2-point charges Q and minus 2Q are kept d distance apart. Find the location of the point relative to the charge Q at which potential due to the system of charges is 0. Let us say that the charge Q is located at A, charge minus 2Q located at B. D be the distance between the two charges. Let us denote the point where the potential is 0 as P, okay, which is at a distance from charge Q to the point PBX, and consequently the distance from charge minus 2Q to the point P, let us take it as D minus X. The electric potential V at point P due to both the charges can be expressed as Vp is equal to Vq plus V of minus 2Q. We have to find out the total potential due to the system of charges is 0. So we can setting up the equation Vp is equal to 0. So put the values of Vq and V minus 2Q in the equation. So what do you get? 1 divided by 4 pi epsilon naught Q divided by X, that is a potential due to Vq, okay, plus 1 divided by 4 pi epsilon naught, and potential due to this minus 2Q charge, so minus 2Q divided by the distance between P and B is D minus X. Equate this to 0. So what we get? 1 divided by 4 pi epsilon naught Q divided by X will be is equal to, there is a minus sign, so I am taking it to the other side, 1 divided by 4 pi epsilon naught 2Q divided by D minus X. So 1 by 4 pi epsilon naught will get cancelled out, Q also will get cancelled out. So what is remaining? You have 1 divided by X will be is equal to 2 divided by D minus X. So simplify it. 2x will be is equal to D minus X, or 2x plus X will be is equal to D. So 3x is equal to D, or the distance x is equal to D divided by 3. So that is the final answer. In a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 power of minus 3 meter square, and the separation between the plates is 3 millimeter. Calculate the capacitance of the capacitor. Second question, if this capacitor is connected to 100 volt supply, then what would be the charge on each plate? Third question, how would the charge on the plate be affected if 3 millimeter thick mica sheet of dielectric constant K is equal to 6 is inserted between the plates while the voltage supply remains connected? So here what is given? As per the question, A is equal to 6 into 10 power of minus 3 meter square, and D is equal to 3 millimeter, convert into meter, which is equal to 3 into 10 power of minus 3 meter, and dielectric constant K is equal to 6. These are the parameters given. Voltage is equal to 100 volt. The capacitance value can be calculated using the formula C is equal to epsilon naught A divided by D. Substitute the values. Epsilon naught is 8.854 into 10 power of minus 12 into A is 6 into 10 power of minus 3 divided by 3 into 10 power of minus 3. If you substitute the values, what do you get? solve it. So you get it as C value which is equal to 17.7 into 10 power of minus 12 farad. So that's the answer for the first part. And for the second part, if the capacitor is connected to 100 volt, what would be the charge? So for the second question, okay, Q is equal to C into V. So what you get? 17.7 into 10 power of minus 12 into 100 volt. So you get the answer as, okay, 17.7 into 10 power of minus 10 coulomb. That is the charge. For the third question, how would the charge on the plate affected if a 3 millimeter thick mica sheet of K is equal to 6 is inserted between the plates while the voltage supply remains connected? Okay. So to calculate the new charge, so for third question, new charge Q dash is equal to, you can write it as dielectric constant into the charge Q, which we already calculated. So 6 times 17.7 into 10 power of minus 10. So what do you get here? 1.062 into 10 power of minus 8 coulomb. A parallel plate capacitor filled with mica having epsilon R is equal to 5 is connected to a 10 volt battery. The area of the parallel plate is 6 meter square and separation between them is 6 millimeter. Find the capacitance at stored charge. Given epsilon R, that is 5, voltage which is equal to 10, and area is equal to 6 meters square. Separation between them is 6 millimeter. So D is equal to 6 millimeter. Convert into meter. 6 into 10 power of minus 3 meter. So these are the parameters are given here. Now the first part, you have to calculate the capacitance at stored charge. The capacitance of a capacitor in the presence of a dielectric medium is given by epsilon R epsilon naught A divided by D. So you also know that K is nothing but the dielectric constant, that is epsilon R. Okay. So epsilon naught A by D into epsilon R. Put the values here. So 5 into 8.854 into 10 power of minus 12 into 6 divided by 6 into 10 power of minus 3. So what do you get? If you solve this, you get the answer as 44.25 into 10 power of minus 9 farad or 44.25 nano farad. That is a capacitance value. So we have calculated the capacitance. Now the stored charge, second part. So the stored charge is how much? Q is equal to C into V. So what do you get? 44.25 into 10 power of minus 9 into 10. So you get it as 40 or 442.25 into 10 power of minus 9 coulomb or 442.25 nano coulomb. That is the stored charge. 2-point charges Q1 is equal to 10 into 10 power of minus 8 coulomb and Q2 is equal to minus 2 into 10 power of minus 8 coulomb are separated by a distance of 60 centimeter in air. Find what distance from the first charge Q1 would the electric potential be 0. Second one, also calculate the electrostatic potential energy of the system. So let Q1 is located at this point and Q2 is located at a point and they are separated by a distance of 60 centimeter. So let us find out at a point P where the electrostatic potential be 0, which is at a distance of x from the point charge Q1, and this 60 centimeter, when you convert into meter, I can write it as 0.6 meter. So I can say that it is 0.6 minus x is the distance between P and the second charge. Therefore, the total potential at the point is the sum of the potential due to Q1 and Q2. Therefore, V is equal to K q1 divided by x plus k q2 divided by 0.6 minus x is equal to 0. Substituting the values, so which implies k q1 is 10 into 10 power of minus 8 coulomb divided by x, which is equal to, because this is a negative charge, so k into 2 into 10 power of minus 8 divided by 0.6 minus x. So 10 power minus 8, 10 power minus 8 get cancelled out, k will get cancelled out. So what is remaining? So 10 divided by x will be is equal to 2 divided by 0.6 minus x. Cross multiply 10 into 0.6 minus x, which is equal to 2x, or 6. 10 into 0.6 is 6 minus 10x will be is equal to 2x. So 6 is equal to 12x, or x is equal to 6 divided by 12. So which gives me the value x is equal to 0.5 meter. X value is 0.5 meter from the charge Q1. 2-point charges Q1 is equal to 10 into 10 power of minus 8 coulomb and Q2 is equal to minus 2 into 10 power of minus 8 coulomb are separated by a distance of 60 centimeter in air. Find what distance from the first charge Q1 would the electric potential be 0. Second one, also calculate the electrostatic potential energy of the system. So let Q1 is located at this point and Q2 is located at a point, and they are separated by a distance of 60 centimeter. So let us find out at a point P where the electrostatic potential be 0, which is at a distance of x from the point charge Q1, and this 60 centimeter, when you convert into meter, I can write it as 0.6 meter. So I can say that it is 0.6 minus x is the distance between P and the second charge. Therefore, the total potential at the point is the sum of the potential due to Q1 and Q2. Therefore, V is equal to K Q1 divided by X plus K Q2 divided by 0.6 minus X is equal to 0. Substituting the values, so which implies K Q1 is 10 into 10 power of minus 8 coulomb divided by X, which is equal to, because this is a negative charge, so K into 2 into 10 power of minus 8 divided by 0.6 minus X. So 10 power minus 8, 10 power minus 8 get cancelled out, K will get cancelled out. So what is remaining? So 10 divided by X will be is equal to 2 divided by 0.6 minus X. Cross multiply 10 into 0.6 minus X, which is equal to 2x, or 6. 10 into 0.6 is 6 minus 10x will be is equal to 2x. So 6 is equal to 12x, or x is equal to 6 divided by 12. So which gives me the value x is equal to 0.5 meter. X value is 0.5 meter from the charge Q1. Second part of the question, the electrostatic potential energy. Okay, so let us write the electrostatic potential energy of a system of 2-point charges is given by U is equal to K into Q1 Q2 divided by R. So R we know that, which is equal to 0.6 meter. Q1 which is equal to 10 into 10 power of minus 8 coulomb. Q2 which is equal to minus 2 into 10 power of minus 8 coulomb. Put these values in this equation. So U is equal to K is 9 into 10 power of 9 into 10 into 10 power of minus 8 into minus 2 into 10 power of minus 8 divided by 0.6. So if you simplify this, what you get? Minus 180 into 10 power of minus 7 divided by 0.6, which is equal to minus 30 into 10 power of minus 7 joule, or minus 3 into 10 power of minus 6 joule. So electrostatic potential energy U is equal to minus 3 into 10 power of minus 6 joule. The electric potential V as a function of distance x are shown in figure. So V as a function of x, so 0 to 2, 2 to 4 and 4 to 6. We also know that the potential decreases as we move from weaker to a strong electric field. So that is E is equal to minus dV divided by dx. So as per this equation, when you look at the graph, okay, the from 0 to 2, the slope of this graph, that is V by x, gives the electric field. So let us take from 0 to 2, okay, the slope of this graph, that is slope of this graph gives what? Electric field. So dV divided by dx. So as per this graph, the value is positive, the slope is positive here, correct? But as per this what? Electric field, so when you put that value here, dV by dx is positive, but there is a minus sign, so the electric field is negative, okay? So electric field is constant and which is negative due from 0 to 2 seconds. So according to this, electric field is negative corresponding to this point, okay? Then from 2 to 4, as you can see here, the potential is constant, okay, and the slope is 0. So therefore electric field is equal to 0, that is corresponding to this portion, that is the second region. And the third region, then from 4 to 6, okay, you can see that here the slope is negative, E is equal to, as per this, so you get it as minus dV divided by dx. So you get a negative slope, okay, and the slope is constant. So what happens if you put back in this equation, what you get? Minus of minus dV divided by dx. So you get, okay, a positive value for the electric field. So electric field will be positive for this region. So the correct option is this one, option A. Represent vectorially the direction of the force between the charge for Q1, Q2 greater than 0, Q1, Q2 less than 0. So here for the first case, for Q1, Q2 greater than 0, Q1, Q2 greater than 0. So the Q at this point, okay, and another charge, that is Q1 at this point and Q2 is at the point which is located at a distance of R21. So since Q1, Q2 greater than 0, these two charges are positive. So F12 will be in this direction and F21 will be in the opposite direction. And for second case, Q1, Q2 less than 0. So Q1 will be here, Q2 will be here, which are separated by the distance R21. So the force, the direction of force will be, okay, in this direction. F12 will be here and F21 will be in this opposite direction of F12. So this is F21 and F12. So which is separated by are 1. So Q1, Q2 less than 0. So this is the diagram for Q1, Q2 greater than 0, and this is the diagram for Q1, Q2 less than 0.